Hello and welcome to Security Academy. Today's topic is the Diffie-Hellman Key Exchange. What is the Diffie-Hellman Key Exchange? Diffie-Hellman is an encryption algorithm that uses a public channel to send a private message between two users. How does it work? Say we have two users, Alice and Bob. Alice and Bob have to agree on the same secret key to use in order to send messages to one another. Alice and Bob agree on two prime numbers, P and G, where G is the generator and P is large. P and G can be known by the public. Public knowledge of this information will not give access to Bob and Alice's shared key. After determining P and G, Alice and Bob must choose their own numbers, A and B. Suppose Alice picks A. She then calculates G to the A mod P. Suppose Bob picks B. He then calculates G to the B mod P. Alice then sends her total value, G to the A mod P, to Bob. Using Bob's chosen value, B, and Alice's total value, G to the A mod P, Bob calculates the shared secret key value by raising Alice's total value to the power of Bob's chosen value, G to the A mod P all to the power of B. This is equal to G to the power of A times B mod P. Alice then does the same thing using her own chosen value, A, and Bob's total value, G to the B mod P, to calculate G to the B mod P all raised to the power of A. This is equal to G to the B times A mod P. Now, Alice and Bob have their shared secret key. What happens if an attacker comes in between Alice and Bob and tries to intercept their messages? Because the information exchange is performed through a public channel, the attacker has access to some components of the secret key through the exchange of G, P, and Bob and Alice's total values. Using only this information, the attacker cannot arrive at the shared secret key. For example, suppose G equals 3, P equals 11, Alice chooses 4 as her chosen value, and Bob chooses 3 as his chosen value. Then, Alice's total value equals 3 to the 4 mod 11, which is equal to 81 mod 11, which is equal to 4. Bob's total value is equal to 3 to the 3 mod 11, which equals 27 mod 11, which is equal to 5. Then, Alice sends her total value, 4, to Bob, and Bob calculates the shared secret key of 9. Bob sends his total value, 5, to Alice, and Alice calculates shared secret key of 9. So, in this scenario, Alice and Bob agreed on a shared secret key of 9. In this case, the attacker would have the values G equals 3, P equals 11, Alice's total of 4, and Bob's total of 5. These numbers cannot be combined in any logical way to easily arrive at a shared secret key of 9. In a real implementation of this process, the standard procedure is choosing a p-value that is at least 1024 bits. When p is greater than or equal to 1024 bits, it can be assumed, given current technology, that Diffie-Hellman is difficult to solve. Attackers, however, can take a different approach to communicate to both Bob and Alice. Diffie-Hellman is prone to the man-in-the-middle attack, which attackers use to make Bob and Alice agree on a different key. The man-in-the-middle attack works as follows. Say we take the previous example where Bob has a chosen value of 3 and a total value of 5, and Alice's chosen value is 4, and her total value is also 4. Suppose we have a man in the middle, Maeve. Maeve will pick her own chosen value, M equals 9. Maeve will intercept Alice's total value, 4, when she intends to send it to Bob. Maeve will then send 4 to the 9 mod 11, which is equal to 3, back to Alice as Bob's total value. Maeve will intercept Bob's total value, 5, which he intends to send to Alice. Maeve will then send 5 to the power of 9 mod 11, which is equal to 9, back to Bob as Alice's total. Alice's secret key then ends up being 3 to the 4 mod 11, which is equal to 4. And Bob's secret key is 9 to the 3 mod 11, which is equal to 3. This breaks the process, as Diffie-Hellman is supposed to have identical keys between senders. Eve now has 2 keys to communicate with Bob and Alice separately. This allows her to decrypt Bob and Alice's messages and encrypt her own messages to pass along to them. And that's all for this week's lesson. Come back next week to learn some more security tips and concepts with Security Academy.